Hi guys, welcome again in Eng-Man YouTube channel. So again, we will continue our learning on PVTP software for PVT modeling, PVT analysis. And as I said before, in this video, we are going to talk about binary interaction coefficients. All right, so first thing first, we have already achieved, relatively speaking, good matching for, saturation pressure, and then GOR, and then liquid density for the oil. And we haven't used the BIC, binary interaction coefficients. And of course, if we want to be as good as possible, we still want to improve the quality of the matching. And we can achieve that by the use of binary interaction coefficients. Okay, so here we will utilize the binary interaction coefficients in expectation that we can improve the quality of the match, especially for the calculated saturation pressure. By the way, with this in mind, there is no direct need for the use of binary interaction coefficients, actually. However, they could still be used, although with very small values, but we can use them to provide the regression with additional degree of freedom, additional flexibility. Okay, to do that, we go to the binary interaction coefficient input inside the pseudo properties. So we have completed this section pseudo properties and then split pseudo, right, in previous videos. Now we go to BIC input data. Okay, here at binary interaction coefficient, still unchecked, we need to check at binary interaction coefficient. And simply we can calculate this button. And you can see now we have the binary interactions between CO2 and C1, and then C2 and C1, and so on and so forth. Of course, there is no interaction between, a component with itself. So that's why here they are blank. But indeed, there will be interaction between CO2 and C1, CO2 and C2, CO2 and C3, and so on and so forth. Okay? And again, just calculate. So now we have different type of fluid, different fluid, so that we need to actually recalculate both the separator threads and the phase inflow. We can just click on this calculate objects, very easy, and just go directly to phase inflow. Results plot. You see it's not very good, right? Now we have worse the matching for the saturation pressure. Okay, now our calculated or predicted saturation pressure is significantly larger than the lab data. Okay, why? It's because the BIC, the values for the BIC, that are generated are indeed too large, too big a value. Okay, so we will limit the value for the BIC because in fact, the interaction between two components are not actually that strong. So it's quite justified. It makes sense that we put limit on the BIC that can be used. So we are going to use this one, set max value to, in this case, 0.005. You can change it and it's sort of trial and error, actually. But you can also put limiting maximum value of 0.01, something like that. But in our case today, it's 0.005. Don't forget, in my computer, it's comma instead of dot. So just press calculate. Okay. And then go back Here, calculate objects. Done. Okay, go back to phase envelope. Boom. Now it's very, very, very good. Okay, maybe we can, sorry. Still larger than the lab data, but it's significantly better than the previous one with, open BIC value. Now, after we limit the BIC to be maximum at 0.005, now we can achieve significantly better match. Okay, so yeah, again, you can also check the results table. You get the temperature, saturation pressure, the critical temperature, critical pressure, criticondensitherm temperature, criticondensitherm bar pressure. And again, go back to the saturation pressure curve. Okay, so I think that's all. I hope you enjoy this video. I hope this video is useful and thank you so much. See you again in the next PVTP videos. Thank you.